In this video, we are going to discuss about an issue that poses serious problems when it comes to inductive reasoning, or in other words, when you try to generalize. It's the sampling bias. In a way, sampling bias represents the root of what we call hasty generalization. We will start with a simple example drawn from prehistorical times. Do you know why cavemen were called cavemen? Well, actually, it's because the only drawings that survive to these days are the ones our ancestors did in caves. We have made numerous discoveries of drawings in caves. Much less artifacts made of wood survived until today. Because, wood rots. Whatever they did on wood or on materials that cannot stand the test of time rarely survived to the point where scientists could study them, at least when scholars wrote their first thesis on the topic. We can safely assume that they were focused on what was left in the caves, hence the name caveman that was coined. Despite of the fact that a lot of prehistorical people, possibly more than in the caves, lived in forest or coastline. But because of this sampling bias, sampling of artifacts, we often associate prehistory to living in caves, while it's probably a very, very tiny proportion of them that did. So sampling bias occurs when you try to make a generalization out of a sample that was not constituted in a rigorous fashion. Let me give you another example based on data this time. It is common to read that people cheat so much that in relationships, that a very important proportion of fathers are not the real biological fathers of the child. I have read on countless occasions that up to 50% when it comes to the third child, the father is not the father biologically speaking. Imagine the kind of harm that such generalizations can make. That's giving the kids suspicious looks and so on. Well, what such articles usually fail to say is that their conclusions are not drawn from a random sample of families taken in the population, where paternity were tests taken in the population. No, the generalizations were done based on the data from people who voluntarily came to do paternity tests. And one does not randomly walk into a lab to ask for a paternity test. You usually do that when you have a reasonable doubt regarding whether you are the father or whether your father is actually your biological father. And actually those doubts are often grounded in some kind of reality. And that's why we get some results like that half of the third children that go into labs and do the test have little surprises. But it doesn't mean that because of this data, you should generalize that to the whole population. And that is a mistake that many people do, and that has been debunked in the newspapers, in media, on several occasions. But I guess a title like only 50% of the third children that go into laboratories have shown these surprising results would be less attractive, less catchy. And that's why it's easier and more interesting for not so scrupulous news journalists or scientists sometimes to draw conclusions based on a very biased sample. Another example with coronavirus, for a change. At the beginning of the pandemic, people were astonished by the low lethality rates in countries such as South Korea. Well, it is probably due to the huge amount of tests the countries carried out. The more people you test, the more people test positive. And the lower the ratio between deaths and positive cases become. That's not normal. No need to search for explanations in terms of immune system or quality of the health system or whatever. Of course, you should look at demographics in South Korea and other similar explanations, but you certainly cannot take sampling bias out of the equation if you want to explain low lethality rates. On YouTube, you can find a few videos worth watching if you want to know more about how to design a robust sampling method and keep sampling biases in check.